Today we're going to look at second order difference equations. So this time I might define a sequence Tn in terms of, let's say, minus 2 t sub n minus 1. So this is like what we had the last day. So we have the next term is a multiple of the previous term. But I'm going to add an extra bit now. I'm going to say plus 8 t sub n minus 2. So now we're defining a term in terms of the term before that term. So we're defining the nth term in terms of the term before the nth term, but also two terms before the nth term. So this is called a second order difference equation because we're defining a term in terms of two previous terms. So it's second order. And it's still homogeneous because every term in the equation is a term in the sequence. If we had like a plus 8n, for example, this isn't a term in the sequence. So now we've got inhomogeneous because it's not all the same stuff. Remember, homo means the same. So the question is, how could we solve these? One thing you might guess is, well, maybe the solution is the same as the other ones. Maybe it's a times r to the power of n. And if you said that, you'd actually be correct. Maybe that's satisfying enough for some of you, maybe it's not. Remember, I'm going to be making extra videos kind of justifying everything. But again, in these videos, I just want to go through the stuff that's actually going to matter for your exam, but still showing somewhat where it comes from. So let's just say we guessed this was the solution, and let's just run with it and let's see what happens. So if this was the solution, we could say that t sub n minus 1 would be equal to a times r to the n minus 1, and t sub n minus 2 would be equal to a times r to the n minus 2. So now we can sub into this equation and figure out what a or r is going to be. Remember how we did that for the previous ones as well? Even though in the previous ones it was obvious, we still subbed in it anyway. In these questions, you might assume that r could be minus 2 or 8, but again, I want to show things rigorously, so we're gonna sub this in, and we're gonna see that it's not actually minus 2 or 8. It's gonna be something a little bit different, and it was actually pure coincidence that in the first order ones, r just happened to be the number multiplying by. Because when we do it this time, we'll see we're gonna have a times r to the power of n will be equal to minus 2 times a times r to the n minus 1. Then we'll have plus 8, and then we'll have a times r to the n minus 2. So what we're going to get here is we can cancel out all the a's, divide everything by a, and we'll get r to the power of n equals minus 2. And I'm going to write this as r to the power of n divided by r. That's the same as r to the power of n minus 1 by exponent rules. Plus 8, and then we're going to have r to the n, and this time I'm going to divide this one by r squared. The reason I wrote these like that is because now I can cancel an r to the power of n across, and what we'll get is 1 equals minus 2 over r plus 8 over r squared. And then we can simplify this equation a bit. We can multiply across by r squared and get that r squared is equal to minus 2r plus 8. And you might notice something now, that r is not just the numbers in front, it's actually going to be the solutions to this quadratic. And what we want to notice is that the solutions to this quadratic, the quadratic itself looks very similar to our starting equation. Notice that our highest order term is an r squared, the next one down is an r, and the last one down is r to the power of 0. So that's just something important to remember. I'll show that in the general solutions when I kind of do a summary video. But just keep that in mind so that next time you can kind of just skip these steps and you can say this is r squared, this is r, and this is a constant. But I'll talk about that in a bit more detail. Instead of subbing all this stuff in, that's just a little shortcut. Let's figure out what r is though. So solving this quadratic, we bring everything to one side. R squared plus 2r minus 8 will be equal to 0. So factors of 8 are... that would add up to 2 minus, well, we could say positive 4 and minus 2, that would work. So we could have r plus 4 times r minus 2 equals 0. And you could check that if you want by multiplying this out. So that means we get r equals minus 4 or r equals 2. And these are both solutions to our difference equation. So remember last time we got our solution by subbing in. This time we have two solutions. So our solutions, if I take my Tn here, so Tn is equal to this. So our two solutions are going to be Tn equals a times minus 4 to the power of n. That's one solution. And our other possible solution is that t sub n is equal to a times 2 to the power of n. Okay, and you can sub both of these into this difference equation, and you'll see that it will be equal on both sides, kind of like I did in the first order one. Again, I'm not going to do that. That's kind of for the more explanatory videos. But we do have a problem, and I want to kind of show the context for this problem. So these are two possible solutions, but the problem is, let's say I wanted to find out what the second term was. Okay, so I'm going to take my difference equation, I'm going to let n equals 2, and I want to see what happens. Then the second term would be equal to minus 2 times the first term plus 8 times the 0th term. So this time, remember in the first order ones, we needed to know t0 and we need to know the pattern. Here, to get to the next term, we need to know t0 and t1, okay? So in the question, they'll tell you, for example, I don't know, they might say t0 equals 1 and t1 is equal to 4, just for argument's sake. So we have two initial conditions. Now, the problem is, if we try to use one of these solutions, let me just take tn, let me just take this solution. And remember that, as I said, t0 is equal to 1. So that would be equal to a times minus 4 to the power of 0. So that would mean that a is equal to 1. Okay, so cool. And then you might be like, nice, we have our solution. Tn is equal to minus 4 to the power of n. But obviously this breaks down, because with this solution, if we get t1 would be equal to minus 4. But I said that t1 is equal to 4. So something kind of went wrong here, clearly. And basically, the problem is that we have two starting conditions that we have to take into account, but we only have one variable to take both of those conditions into account. So one variable isn't really enough, because as you can see, if we use t0, we get one answer for a, but then it doesn't agree with the other answer. So what we need is we need two different variables, because if we have two different variables, then we can use those as the starting conditions. We solve simultaneous equations, and that makes sure that it all works out. That might not have made sense, but you'll see now when I do an example. So basically, we need a way to get a solution that's going to have two constants. And how can we do that? Well, one way that we can do it, and again, I'll prove why this works properly in the extra videos, is we can add these two solutions, okay? So basically, I can say that Tn will be equal to some number a times minus 4 to the power of n, plus a different number, you could call it b, times 2 to the power of n. Why did I call it a here, but here I called it b? Because I want these two numbers to be different, and it doesn't matter what these numbers are. They can be anything. You sub this into the equation, a can be anything, and it works out. So this can be a solution, and you can check that this will work by subbing into the original difference equation. But basically, the reason that we can add these solutions and it'll still work is because this difference equation is linear. This is stuff you don't need to know, by the way. This is just quickly explaining. Which means that there's no squaring or anything. So if we're adding these two things, if let's say here with the minus 2, then we'd have a ... plus b ... You can see that these will actually get separated out when we distribute this out. And then we kind of have all the a terms separately, which we know is a solution. We have all the b terms separately, which we know is a solution. So because they're all separate, they kind of cancel each other out. Again, I'll go into more detail about that in the extra videos because you don't need to know that. What you need to know is that when you get your roots, you have two solutions, you add those two solutions. And now we can see why this will work out. Because if I take this solution down here, and I know that t0 has to be equal to 1. And that's going to be equal to a times minus 4 to the power of 0, plus b times 2 to the power of 0. So this tells me that 1 is equal to a plus b. Cool. We don't have a solution yet, but we know also that the first term is equal, or t1 is equal to 4. But t1 is also going to be equal to a times minus 4 to the power of 1, again subbing into this formula up here, plus b times 2 to the power of 1. This tells me that 4 will be equal to minus 4a plus 2b. So now we can solve these two simultaneous equations, and we can get values of a and b so that both of these facts are true. So this is what I was trying to say earlier. Now that we have two unknowns, this allows us to make sure that both of these facts are true, whereas when we only had one unknown, we'd sub in one value and then we'd get an answer straight away. Doesn't take the other one into account. Whereas now, because there's two unknowns, we end up taking both of the first terms into account. We just have to solve these simultaneous equations. I can divide this one by 2, so that 2 is equal to minus 2a plus b, and I can line the other one underneath. I'm going to multiply this equation by 2, and say that 2 is equal to 2a plus 2b. Again, that's just so that we can cancel these out. Say that 4 is equal to 3b. This means that b is equal to 4 over 3. Cool. So what's a going to be? Well, we know that 1 is equal to a plus b, so we can say that a is equal to 1 minus b. That's just rearranging this formula up here. This equation rather. So then we'll have a will be 1 minus 4 over 3, which will be minus a third, which is a. Perfect. So now we know what our final solution is. So again, this is our solution. So our final solution, now that we've figured that out, will be Tn is equal to minus a third times minus 4 to the power of n plus, what was b? It was 4 thirds times 2 to the power of n. You might ask, does it matter what order a and b are in? The answer is, Up here, the order doesn't matter because they're both unknowns. However, when we're subbing back in, it's really important that we sub them back in the right places. If I found out that a is minus a third, a means the number in front of the minus 4. If I put minus a third here, that'll be completely wrong because this isn't what a is, this is what we called b. But when you're giving them names, it doesn't matter because they're just unknowns that we can solve for. And this is our final solution. It seems a little weird because we have fractions, but I can guarantee you, if you sub in t0, you will end up getting 1. If you sub in n equals 1, you'll end up getting 4. And then you could calculate using the difference equation. Where was our original difference equation? Here it is. I'll do a little quick calculation just to kind of prove that this works. So if I said that if I want to find out the second term, t2, it'll be minus 2 t1 plus 8 t0, which is equal to minus 2 t1, remember, is, what did we say t1 was? It was 4, wasn't it? T1 was 4 at the start. Yep. So T1 is 4. So we'll have minus 2 times 4 plus 8. And then T0 we said was 1. So the second term should be 0 according to this. Okay. And we can double check that our formula actually works. Let's take this. So T2 should be minus a third times minus 4 squared plus 4 over 3 times 2 squared. And let's just see if this actually works. So minus 4 squared is 16. So we'll get minus 16 over 3 because this is going to be positive, and then we're multiplying by something negative. Plus, and then this is going to end up being 4 by 4, which is 16 over 3. Hey, look, it ends up being 0. So yeah, this equation works. And this is a solution. You can sub this into the original difference equation, and you'll see that will indeed work. To summarize, here are the steps. So the first thing is we need to find r, which is the root. So remember that we have r to the power of n in our solution. So if we have this as our equation, so this is just bringing all the terms to one side because we know we're going to have to solve a quadratic, so you may as well do that. And this is the exact same as this, okay? Remember how I said it doesn't matter if it's n and n minus 1 and n minus 2? The only thing that matters is the order. So for example, this is the highest term, this is the second highest term, and this is the lowest term. So what happens, you can sub in like we did it in the video if you want, but if you want to do it as fast as possible, which you want to do in the applied maths exam, is you take the highest term, and that's going to be r squared. The second highest term will be r, and the lowest term will just be a constant. Or if you want to think about it the other way, building it up, the lowest term is a constant, the next highest term is an r, and the highest term is an r squared. And this applies for our other ones. So for example, remember when we did like tn is equal to 2 tn minus 1? You can do the same thing. Let's say this is our constant, and then we build it up. This is our r. So we'd have that r is equal to 2. And that's what we had. Remember that we ended up having 2 to the power of n in those first order ones. So the same method works. You want to use this method for everything. It's covered in my summary video once you get to the end of this. So yeah, maybe the easiest way to remember it is start with the lowest one. That's your constant. Then the next one's an r, and the highest one's an r squared. And then for the first order ones, this is an r, and this one's a constant, sorry, and then this one's an r. Again, building your way up from the lowest, which is r to the power of 0, or a constant. So you could say this is r to the power of 0 if you'd prefer. But yeah, so we need to figure out our values for r. So we'll have 2 values for r. Then what we have is that our solution, remember, it's going to be some number times the first r to the power of n plus some number times the second answer to the power of n. So remember for our first order ones, we didn't have this second term. This was just our general solution. But here, because we have 2 solutions and we have 2 initial conditions, we have to write it like this, okay? Again, the reason being because we need 2 unknown variables so that we can use both 2 initial conditions, t0 and t1. If we only had the a, remember we run into the issue that we ran into earlier because we only had 1 variable to kind of use 2 conditions with. And then final thing we have to do is figure out what a and b are. Then we can use, we basically use t0 and t1 to find a and b with simultaneous equations. And then we've got our solution. So I'll put up on screen some of the questions you can try. So here are questions from past exams with the second order homogeneous. So a lot of these mix in second order inhomogeneous in the second parts. That's why I've only said certain parts like 1 to 3. Then part 4 has inhomogeneous. But it's cool that it comes up pretty much every single year, even just a homogeneous one. So yeah, give those a go for practice if you'd like.